This is an introduction to balancing chemical equations. We're going to talk about what it means for an equation to be unbalanced or balanced, and then we'll learn the process that you go through to balance a chemical equation. I want to start with a few examples that show the concepts behind balancing equations, so you can really understand what's going on when you work through these kind of problems. We'll begin by looking at this chemical reaction. Hydrogen gas and chlorine gas combine to make hydrochloric acid. So this is how we can express this chemical reaction using words, and we often call this kind of thing a word equation. Now, we can use this word equation to write a chemical equation by taking each one of these things and writing the chemical formula for it, okay? So the chemical equation looks like this. Hydrogen gas, its chemical formula is H2. We have and, the plus. Chlorine gas is Cl2. We get the arrow. And then hydrochloric acid, its chemical formula is HCl. Okay, now if I wanted to be really precise about things, I could put a G in parentheses next to each one of these to show that they're gases, but I'm trying to keep things simple for this video. Now, in order to start talking about equation balancing, which is the topic of this video, we have to look at the atoms in this chemical equation. We have to look at the number and type of atoms that we have on both sides of the arrow. I've got some diagrams here so we can do this visually, so we can actually see the atoms and how they recombine during this reaction. Okay, so we got a molecule of hydrogen gas. It looks like this. We got 2 hydrogen atoms, 1, 2. Then we got some chlorine gas. We got a molecule of that. 2 chlorine atoms. Got our arrow, and finally a molecule of hydrochloric acid. So there it is, 1 hydrogen and 1 chlorine. Okay, so now we're going to start talking about balancing equations and balanced equations. First thing that I want to do is figure out whether this equation here is a balanced equation. So here's the definition for balanced equations. A balanced equation has the same number of each type of atom on both sides of the arrow. Okay, so keeping this definition in mind, what I have right here, is this a balanced equation? No, it's not. Here's why. On this side of the arrow, I have 2 hydrogen atoms. Over on this side, I only have 1. Over here, I have 2 chlorines, and over here, I only have 1. So this is not a balanced equation. We don't have the same number of each type of atom on both sides. This isn't a balanced equation, so we call it an unbalanced equation. Unbalanced is just the word for an equation that's not balanced. It has different numbers of one or more of the types of atoms on the 2 sides of the arrow. Okay, so this is currently an unbalanced equation. Now, most of the time in chemistry, unbalanced equations aren't particularly useful to us, and we have to make them balanced before we can use them for problem solving or for doing calculations. So often in chemistry, we start out with unbalanced equations, and then we have to figure out how to balance them. So in order to balance this, we're going to make a few adjustments. Here's how we do it. To balance the chemical equation, we change the number of these molecules that we have, and we find a combination that gives us the same number of each type of atom on both sides. Okay, it's a little bit like a puzzle. So it might turn out that to balance this equation, we need 3 of these and 1 of these and 3 of these. Or we might need 2 of these and 2 of these and 1 of these. So we play around with the number of each one of these that we have, finding a combination that gives us the same number of each type of atom on both sides. Okay, so take a look at this equation. Can you figure out what we need to do to 1 or more of these in order to have the same number of each type of atom on both sides? Well, here's what we do. We have 2 hydrogens here, 2 chlorines here, 1 hydrogen, 1 chlorine. So if I get another one of these, okay, if I have 2 of these, we'll then have 2 hydrogens here, 2 hydrogens on this side, 2 chlorines on this side, 2 chlorines on this side, and now this equation is balanced. Okay, so we've balanced the visual version of it. To balance the written equation, what we'll do is we'll put a 2 in front of the HCl here to show that we have 2 of these. And now the equation is balanced. Okay, so this is the combination. This is the combination of these things and these things that we need to have the same number of each type of atom on both sides. We need one of these, and 2 of these to end up with a balanced equation. Here's another chemical reaction. Hydrogen gas and oxygen gas combine to make water. The chemical equation for this looks like this. The chemical formula for hydrogen gas is H2, then oxygen gas is O2, and these combine to make water, which is H2O. Now let's look at how we can represent this visually. Okay? We've got one molecule of hydrogen gas, H2. Then we have one molecule of oxygen gas, O2. We got our arrow here. And H2O, water, is over here. Okay? So just like we saw previously, on this side of the equation is what we start with. It's our before. We've got our reactants, and over here is our after, our products. Okay, so take a look at this equation and these atoms here, and think about this. Is this equation balanced the way it's written here? And the answer is no. It is unbalanced. Here's why. I've got 2 hydrogens here and 2 hydrogens here. So the hydrogens do balance, but the oxygens don't. I have 2 oxygens here and only 1 over here. So this equation is not balanced as it's written. In order to change this, we're going to adjust one or more of the numbers of these different compounds. Okay? Here's how we're going to do it. Take a look. I've got 2 oxygens here and 1 here. So the first thing I want to do is I want to try to balance these oxygens. To get more oxygens on this side, to get 2 oxygens on this side, I'm going to add another one of these H2O. So now I have 2 of them. All right, so I have 2 oxygens here, 2 oxygens here. The oxygens balance. But check this out. By adding this water here, I changed something else. My hydrogens used to balance, but now I have 4 on this side. I only have 2 on this side. But that's okay because I can change the number of these as well. Okay? I used to have 1, so let me add another hydrogen here. Now I have 4. 1, 2, 3, 4 hydrogen atoms over here, and 1, 2, 3, 4 hydrogen atoms over here. Okay, so now this is a representation of how the atoms balance. In order to balance the chemical equation up here, I'm going to put a 2 in front of the H2 because I have 2 of those, and then I'm going to put a 2 in front of the H2O here because I have 2 H2Os, and now the equation is balanced. Here's a really common mistake I got to tell you about. When people are first learning this stuff, a lot of the times they'll say, hey, I have a simpler way to balance this. Here's how you do it. Get rid of this 2 here, get rid of this 2 here, and then just put a little number 2 right under this O here. Now you have H2 on this side, H2 on this side, O2 on this side, and O2 on this side. It balances perfectly. Yeah, but unfortunately you can't do that. These numbers here, we call them subscripts. You can't change them when you're balancing an equation. They have to stay the same. And here's why. In this equation, we're talking about water. Its formula is H2O, and this is what a water molecule looks like. If you put a 2 here, we're not talking about water anymore. We're not talking about H2O anymore. We're talking about a molecule like this with 2 oxygens and 2 hydrogens. This isn't water. This is now a compound called hydrogen peroxide. So yeah, by adding this 2, you might balance the equation, but it's no longer the equation for hydrogen gas and oxygen gas making water. It's now the equation for hydrogen gas and oxygen gas making hydrogen peroxide. You totally change the meaning of the equation if you mess around with these subscripts. So you can't do that. The subscripts have to remain the same, but you can put numbers in front of one or more of the compounds, but the numbers always have to be in front. You can't modify any of these subscripts. When we first start off talking about balancing equations, I love to use visuals like these of the atoms and molecules so you can really see what's going on. But when you're going to be balancing equations on homework or on quizzes, you're not going to be using drawings like this. Instead, you want to be able to balance equations using charts, doing a little bit of math. So I'm going to show you one example here of how you do that. Okay? So in this equation, we have nitrogen and hydrogen. Now obviously we have those on both sides. So I've made this little chart, nitrogen and hydrogen on both sides. So the first thing you want to do is you want to write in your chart how many of these atoms you have, right? So we have N2, so that means that we have 2 nitrogens on this side. You can see that from the diagram. H2, we have 2 hydrogen atoms on this side, and then we have the arrow. And then over here, we have N, so we have 1 nitrogen atom, and then we have 3 hydrogen atoms. So to start balancing this, you want to look at where you have an imbalance of atoms, where you don't have the same number of atoms, and you want to think about what you could multiply one of these compounds by. Okay, so let's look at nitrogen right here. We have 2 nitrogens here, we only have 1 here. Okay? So one thing that we could do to start out balancing this is we could put a 2 in front of NH3 here. So that would multiply this whole thing by 2. So now we'd have 2 of these, and that would give us 2 nitrogens. And now we have 2 times 3, which is going to give us 6 hydrogens. Okay? So that's how we use this chart. Now that kind of changed these numbers, so let's look at what's going on over here. Okay? So now the nitrogens balance, but now the hydrogens don't balance. I have 6 here, and I have 2 here. Okay? So what could I multiply something by here to fix the hydrogens? Well, I have 2 right now. I want 6. So I could put a 3 in front of this. It would look like this in our visual. Now we have 2 more hydrogens, and that gives us 3 times 2, 6 hydrogens here. So we can keep track of these adjustments that we make using charts like this that show us how many of each atom we have on both sides. We multiply something by a number in front of it, and then we change the number of atoms. So the best way to get good at this is to just do a whole bunch of practice. Check out my video of balancing chemical equations practice problems. You'll do a whole bunch of examples, and it will really make sense.